Welcome to the podcast. Let's dive into the fascinating world of how AI processes human language through natural language processing.
Absolutely. It's such a rich area. Yeah. Especially when you consider all the layers that go into it.
Right. So at its core, NLP blends linguistics, computer science, and machine learning to help computers understand text, right?
Mm-hmm.
It's like taking our language and turning it into, something a machine can chew on.
Exactly. It breaks language down into tangible parts. Speaking of which, what do you think about the first steps like tokenization?
Tokenization is pretty fundamental. It's basically the process of chopping text into words or sentences so that subsequent analysis becomes manageable.
Yep.
It's like taking a sentence and breaking it apart piece by piece, kind of like taking apart a puzzle, right?
For sure. And that puzzle analogy works nicely in showing how each token plays a role in the whole picture. So then, once we have tokens, there's part of speech tagging.
Yes, POS tagging is key. It assigns grammatical labels like noun, verb, adjective, basically telling the system what role each word plays. Without it, the machine would have a hard time discerning if running is an action or describing a thing, like in running shoes.
That nuance is crucial. And then moving on, I guess named entity recognition, or NER, is another major piece of this puzzle.
Exactly. NER identifies specific entities, names, organizations, locations that are embedded in the text.
Yeah,
it helps
correct.
the system understand the context around people, places, and things mentioned in any text.
That really sets the stage for deeper language understanding. But then there's also the role of parsing, like analyzing sentence structure.
Parsing goes beyond mere words. It's about how words relate to each other in a sentence. For instance, dependency parsing shows which words depend on others, and constituency parsing organizes words into phrases. It brings clarity in complex sentences, like resolving that classic ambiguity. I saw the man with the telescope.
Yeah, exactly. It ensures the system knows who had the telescope. Now, I'm really intrigued by how machine learning ties in with these NLP tasks.
Oh yes, machine learning is the engine behind modern NLP. Most of these models are trained on huge data sets using supervised learning, where the system learns from examples that include both the input and the desired output. And then there's unsupervised learning, which finds patterns without needing explicitly labeled data.
Right? And it's that deep learning, particularly neural networks like transformers, that have really pushed everything forward.
Absolutely. Transformers have been a game changer. Their ability to capture context over long stretches of text means they handle language nuances much better than previous models. It's like switching from a bicycle to a rocket ship in terms of performance.
Yeah, totally. And speaking of nuances, word embeddings play such a fascinating role. What can you tell me about them?
Word embeddings represent each word as a vector in a high-dimensional space. Essentially, words with similar meanings end up close together. So, king and queen are near each other, and that helps the model understand semantic relationships.
That's a neat concept. It makes the text more relatable to the machine by making those mathematical representations.
Exactly. And then there's the whole challenge of context and disambiguation.
Right?
Words can be super ambiguous. For example, the word bank could mean a financial institution or the side of a river.
And that's where models like transformers shine, because they look at surrounding words to clear up that ambiguity, yes?
Precisely. Contextual models change a word's embedding based on the neighboring words. It's like having a conversation where you use clues from earlier sentences to understand what someone means.
Yeah, definitely. Now, machine translation is another exciting application, isn't it?
Oh, totally. Machine translation, especially neural machine translation, uses encoder-decoder architectures to map sentences from one language to another. It's impressive how it manages even idiomatic expressions, even if sometimes it stumbles over cultural nuances.
Yeah, and those challenges, like idiomatic expressions, really test the limits of current AI, don't they?
They sure do. And it makes you wonder what might come next. especially as these models begin to address such subtleties with additional context-aware strategies.
Exactly, that's a real frontier for AI. Speaking of frontiers, what about speech recognition? It's another key component where AI deciphers human language in real time, right?
Yes, indeed. Speech recognition involves converting spoken language into text. It relies on both acoustic and language modeling and has seen huge improvements thanks to deep learning.
Totally.
Voice assistants like Siri and Alexa wouldn't work without these advancements.
And if I may, there's sentiment analysis too. I mean, how neat is it that AI can detect the tone or emotion behind text?
Absolutely fascinating. Sentiment analysis classifies text as positive, negative, or neutral.
Right.
And with deep learning, models are even capturing subtleties like irony and sarcasm. Though I have to confess, I sometimes wonder if they always get the nuance right.
I agree. Sometimes the interpretation may be a bit off, but it's continually improving. What's your take on handling the challenges posed by language ambiguity overall?
Well, I believe the key lies in better contextual understanding and training models on diverse data sets. Although I must respectfully challenge the notion that more data alone will solve ambiguity. It's also about how you interpret that data.
Good point.
It's not just quantity, but quality and contextual nuance that matter.
Yes, totally. Balancing complexity with efficiency is definitely tricky. And then there are ethical issues like bias that need addressing.
Absolutely. Addressing bias is critical. As these models become more prevalent, ensuring fairness and transparency in language understanding is paramount.
Right on. And looking to the future, I can see multilingual models bridging language barriers and making communication even more seamless.
Yeah, the future is very promising. We'll see even more sophisticated conversational agents and AI that truly grasps language, not just mimics it. It's like stepping into a whole new era of human-computer interaction.
Exactly. This really underscores how transformative these advances are, from tokenization to deep learning and addressing ethical challenges.
For sure, every component, tokenization, POS tagging, NER, parsing, and beyond, each builds upon the last to create a comprehensive framework for understanding language.
It's been a great conversation, exploring both the technical achievements and the challenges that lie ahead in NLP and AI language understanding.
Indeed, it's a dynamic and rapidly evolving field that constantly pushes the boundaries of what's possible in communication between humans and machines.
Yeah, very exciting times. Thanks for the deep dive into how AI understands human language. It's truly a symphony of science and language coming together.
Thank you, and here's to more breakthroughs as we refine these techniques and tackle new challenges.